All right, so from yesterday, remember what I think the best way to approach these word problems is not just jumping straight in and reading the whole thing. Okay, this might feel like that's not quite as much reading as some of the other problems, but I just focus straight away on what am I trying to solve? Because what I'm trying to solve is going to help me define what I'm going to let the x variable and y variable represent. It says that I'm solving how many yards were rushed by each player. Well, maybe that's not enough context, so I might actually have to go back and read this, but I know that my variables are going to have something to do with yards rushed by some player. Okay, so now I'm like, all right, I'm going to go back and read it because maybe I need a little more context here. It says last season, 2 running backs on the Broncos football team rushed for a combined total of 1,550 yards. One of them rushed for 4 times as many yards as the other. Okay, so all this is telling me is that there are 2 running backs that rush for yards. Okay, so our variables are going to be the yards rushed by each running back. Now, this is where we can be a little specific. I'm going to say X is rush yards by running back number 1. Okay, RB to abbreviate running back. So the number of yards rushed by running back number 1. Y is the rush yards by RB number 2, right? It doesn't specify about one being different than the other. And this problem is a lot like the first homework problem in terms of how the setup goes, because it's a little bit different than the ones we did yesterday. So now I'm going to go back through and underline the math, the important parts that should show up in an equation. So it says both those running backs combined for a total of 1,550 yards. So that means if I take the number of yards by running back 1 and the number of yards by running back 2 and add those together, that needs to get to 1,550 yards. Well, there's my equation right there. Okay, X plus Y equals 1,550. Number of yards by one running back plus number of yards by the other running back. Then it says that one of them rushed for 4 times as many yards as the other, and it doesn't specify which one's which. Okay, that makes this a little bit easier on us. So if I take one of the running backs, let's say X, so number of yards by running back 1, well, they rush for 4 times as many as running back 2. So if I take 4 times the number of yards by running back 2, those are equal. So the number of yards by running back 1 is equal to 4 times the number of yards that running back 2 rushed for. And now we have our equations. Hey, again, this takes practice. Hey, it's not something that if I'm telling you how to do it every time, or if you're having to look at the answer key every time, it's not something that you're going to get better at. Okay, this is a skill, and there's more to it than just the math part, right? There's reading involved in this. Okay, so these really do take good practice, okay, where you're actively thinking about it. All right, now the solving part. The solving part, now the words don't matter, right? Once we have the variables and the equations, now it's just a solving. So I've got X by itself. I'm going to replace X in the equation with 4Y. That makes this 4Y plus Y equals 1,550. So 5Y equals 1,550. And divide by 5. And I get Y equals, calculator for that, 1,550 divided by 5, 310. Okay, once I have one of the variables, I can get the other by plugging it right back in. So I'm going to plug 310 right back into the equation. So X equals 4 times 310. And 4 times 310 is 1,240. Yeah, Ty, go ahead. Wouldn't the first X? You good? Yeah, I plugged it into the other equation. But if I were to plug it into the top one, it'd be X plus 310, and then I just subtract it, and you should get the same value. All right, so now again, our answer is not just x is 1240 and y is 310. We need to answer the actual question here. And again, it doesn't specify. So we can say 1 running back rushed for 310 yards, and the other 1,240 yards. Okay, so just writing some kind of statement answering the question. I'm not going to be that picky and make you write a full-on complete sentence, okay, but at least acknowledging what the question is asking and then answering that. All right, for example 5, let's do this. Let's have you all, you know what, let's make this the last one. We don't need to do example 6. We've seen enough of those. Example 5, let's kind of do how we did this yesterday, where we start by just define variables and build the equations. I'm going to give you about 2 to 3 minutes to do that. Again, all I ask is that you try. Okay, do not need these to be perfect, but what is x going to represent? What is y going to represent? Even better, agree with your group on what those are going to represent, and then see if you can build the equations here. 2 minutes, we'll check there, and I'll give you time to work it out as well. All right. So for the defining of your variables, it should be specific. So you should be saying number of dimes and number of nickels. Okay. Now, if you mix it up, that is okay. If you said y is the number of dimes and x is the number of nickels, nothing is wrong about that. Okay. It's just going to change how we build one of the equations. Okay, but the number part is really important because we know the value, right? That's not something we're solving for. I know that a nickel's worth 10 cents. I know that I know that a nickel's worth 5 cents and a dime is worth 10 cents. Okay, so we're just trying to figure out how many of each does he have. So again, that number part is the specific that I'm looking for. Then it says there's 80 coins in total. So if I add up the number of dimes represented by x, and the number of nickels represented by y, x plus y is 80. No matter how you define your variables, you should have that x plus y equals 80. The next equation is where I'm going to bring the value of each coin in. Okay, so with dimes being 10 cents, that means they're worth 0.1 of a dollar. Okay, so that's 0.1x. If you changed it, if you had y be the dimes, then you'd have 0.1y. That is okay. Then nickels are worth 5 cents. That's 0.05 of a dollar. So 0.05y, and it equals the $6.60 that he earned. Now go ahead and solve it. In your groups, decide how you want to solve it. What method? And then see if you can come up with an answer for x and y. I'm going to work it out as well. And then the rest of the period will be your time to get some homework done. But that doesn't change the process. I still think elimination is easiest. So I decided to eliminate the x's by multiplying that entire top equation by negative 0.1. Okay, the negative part is important because if I don't make one of those variables negative, they're not going to cancel out. Okay, so by me multiplying by negative 0.1, I get negative 0.1x and then negative 0.1y. 80 times negative 0.1 is negative 8. Adding those together, the x's eliminate, and you get negative 0.05y. And then 6.6 minus 8 is negative 1.4. Dividing the negative 1.4 by negative 0.05 is 28. Once I have 28, I plug that right back into definitely the equation without the decimals. So that's the top one. And do 28 plus 52, or excuse me, 80 minus 28 to get 52. Okay, so 28 nickels and 52 dimes. And Dennis's neighbor, I would not be mowing his lawn again if he just gave me a bunch of nickels and dimes to mow his lawn. Come on, neighbor. Give me some real money. All right, we're going to skip 6. We'll be done with that.